Sinkholes cause millions of dollars worth of damage every year and put lives at risk. In this presentation, we're going to look at some ways to detect future sinkholes to prevent future damage and possibly losses of life. In February 2014, there was a collapse at the Corvette National Museum. As you can see in this picture here, it cost over $5 million worth of damage. Different types of sinkholes include dissolution or solution sinkholes. This is a type of sinkhole that forms where limestone underneath the soil or with vegetation over top of it. The limestone bedrock is exposed to nature when it rains, and the runoff goes in the cracks underground and it dissolves over time. This is going to take a very long time, very predictable, not a major concern for any type of construction or anything like that. Cover substance sinkholes are a type of sinkhole where sand is covering the limestone bedrock. The sand starts to flow in the cracks slowly, and the land surface starts to sink down. This type of sinkhole is not a major concern because it's a very slow process. Cover collapse sinkholes are the most dangerous of all of them. These are ones that are very highly unpredictable and happen very fast. The water dissolves the bedrock limestone and creates an underground cavern. This gradually allows the ground sediment to erode, and the cavern from the bottom continues to erode, just a thin layer remaining between the surface and underground opening. Once this occurs, timing is unpredictable, and the sinkhole could go at any time. These are more common in areas like Florida and what happened in Kentucky with the Corvette Museum. It's important to know a historical background of sinkholes in an area. This allows you to kind of plan where you're building your projects and stuff like that to make sure that you're not going to build on an area that's susceptible to sinkhole catastrophes. The United States, historically most common areas of sinkhole formed are Florida, Texas, Alabama, Minnesota, Missouri, Kentucky, Tennessee, Pennsylvania. Just about any place that's going to have a limestone bedrock base and high amounts of water is going to be your optimal zones that you're going to see a lot of sinkholes in. Some causes of sinkholes. Limestone bedrock is the main cause of it. What happens, you either have too much rain where it washes it out underneath, or a lack of rain where it makes an empty cavern where the water used to be. This all can be affected by climate change. Also, there's a lot of different acidity to the water that can help create more erosion faster. These are things that are cause for studies and concerns for the future. Areas where karst terrain is present and the rainfall is significant are areas that are susceptible to formation of sinkholes. There's a need to inform people living in the susceptible areas, teaching people about these areas and about the signs of sinkholes and how to react when signs are present. It's very important to make sure that everyone is educated in these areas so they don't continue to play in them or build a house near them if they understand the signs of it. We also need to look into the human impact of it as climate change is upon us. We need to keep our information coming fresh and good databases all the way through to keep this information available to a lot more people. Now that we have a little history and an idea of what sinkholes are, we're going to look in some ways to detect them and monitor them. This is the ERT method. Basically what this does is this takes an electrical current and it flows through the ground to different sensors placed along an area. When this electricity is flowing through there, it allows the sensors to detect what is under the ground by using the resistivity properties of the different materials. The ERT shows different properties of underground soil, also shows water content in the changing profile. Example of the electroresistivity tomography was used in the study of the western part of Florida at USF Geopark. This area was well known and well researched, and they were testing for accuracy. The picture on the left is a representation of how they would have to set up the test study. They would have to drill holes in. They would have to, you can see the holes right through here. And then you would have your electrical current generator there. And then you would be able to run a current through this whole area here. And it'll be registered and it'll go through. On the right hand side, you can see some of those actual different representations that came from that study. You can see all these colors is one thing in here. These colors do not match up to each graph. They're different values. They're actually the same values. They're just different shades. But if you look in this area here, you can see that they're able to find a sinkhole that they knew about, but they were able to accurately identify it. Now, one side note is this was only able to go down to right around 20 meters deep, which means anything below that you would have to drill too far, which would be a little more time consuming, a little bit more of a problem with that. The ERT is a great option to know exactly what you're looking for under the ground. However, it's quite expensive. The next technique looked at in this presentation is light detection and ranging. This is called LiDAR. LiDAR is coming on very strong. The technology has come very far in a very short period of time. This allows basically a 3D model to be generated by a laser. One case study by the University of Minnesota used LiDAR to map sinkholes in an existing area. This study was designed to reduce the number of man-hours spent locating and mapping sinkholes in the area by automating the process. LiDAR scans are very detailed, but also need conversion to show what the data actually means. It creates a matrix of points that can number in the billions. The team used the karst feature database information and referencing the existing area. The images from LiDAR were overlaid with maps, and they created a 3D scan. Now that they had all these different areas that they were looking at, now they've developed an algorithm where they allowed them to look at different heights and elevations and compare them to known sinkholes in the area. This algorithm, as you can see over here, these are some of the formulas here for the different sinkhole perimeters. This right here is an energy equation for the slope, kind of give you an idea of what math they were using when they were deriving this algorithm so that they could try to save some time with man hours on this. On this slide here, you can see a LiDAR equipped drone over here, and what it actually is producing when it takes those pictures is a 3D map. This is of a tree that this was looking at. This chart over here is basically showing you how they use the different depths versus the area of the sinkholes to try to figure out which ones were the most severe and extreme sinkholes of the original map layout. This over here is the frequency, is your y-axis, and your x-axis is the difference of the adjustment that they had to do from the LiDAR information. In conclusion, early detection of sinkholes is very essential to building safe buildings. The implementation of LiDAR, ERT make the world a safer place by producing more accurate models of the earth below. Personally, LiDAR is the most cost-effective way to detect and monitor sinkhole activity in a region. LiDAR keeps cost by being less invasive to the subject area.